We are team Interrupt Junkies and this is our presentation for Lab 2. In Lab 2, we had to create a controller for a line following robot in Heptagon. We chose to use PID control for the same, as PID control allows for high fidelity in terms of line following. As required, we have clamped motor outputs to between 0 and 100 and the direction is a value between 1 to 4 as required. So let us see a few examples of the same. So the first example we will consider is a wobbly sort of line. We are assuming that the line is a white line against a black background and that the sensor values are between 0 and 50. The reason we assume this for now is that HepTest does not allow for values greater than 50. Obviously, in the real robot where the sensor values goes from 0 to 1023, the KPK, KD parameters can be scaled appropriately. In any case, when the line is perfectly centered under the robot, sensor 2 will have value 50 and the other sensors will have value 0. And as expected, the VL and VD, that is the outputs of the motor, are 70 and 70 and the direction is forward. So the robot is going straight ahead. Now suppose the line wobbles slightly to the left, in which case sensor 1's value will increase and sensor 2's value will decrease as the line shifts from center towards center left. So we would then expect that the right motor will be actuated more and the left motor will be actuated less. And indeed this is the case. So we see that the left motor is actuated less and the right motor is actuated more. And this continues until the line gets aligned under the robot again. And once the line is aligned, the robot's motor values go back to being equalized, and so the robot is again following the line. So in a similar manner, if the line now veers a bit towards the right, then we see that the left motor value is now greater and the right motor value is lesser, and this continues until the line is again aligned under the robot. And now we see that the robot is again aligned under the line. So the first case was of a wobbly line. The second case we'll consider is that of a sharp left turn. So in case of a sharp left turn, what happens is that 3 of the left sensors will have maximum value and the other 2 sensors will have 0 value. And let us see what happens in this case. So the robot is currently going straight and now it encounters the sharp left turn. So sensor 0, sensor 1, sensor 2 all now have max output. So in this case we would expect the robot to take a very sharp left turn. So that is, the left motor output is reversed and the right motor output is maximum. Indeed, we see this is the case. The direction 2 indicates that the left motor is going in reverse and the right motor is going in forward, and the values again indicate that the bot is turning leftwards. And we see that this continues until the robot is again aligned against the line. So this would be something like the left sensors now going off the line as the robot starts to turn into the sharp turn, and we see that now the robot is again going forward. However, the left motor's output is much smaller than that of the right motor, so the robot is still finishing the turn. So as the turn gets over, the robot comes back onto the line, and we see now that the motor outputs will be equalized, and it's now 70 and 70 and the robot is again aligned. In a similar fashion, we can consider a sharp right turn. The final case we'll consider is a gradual left or right turn. So here, just for example's sake, I'll be considering a gradual right turn. So in a gradual right turn, the sensor output is always slightly deviated towards the right. So that would look something like this is the initial state part, and then the slight deviation towards the right would look something like this. And in this case, the motor outputs are again indicating that the robot is veering slightly towards the right, and so the left motor has higher speed than the right motor, which indicates that the robot is going towards the right, and this continues until the turn is over, in which case the sensors are again centrally aligned and the motor outputs go back to being equalized. Thank you.